yes, manufacture more than 10,000 next year. We definitely want to do all the assembly, sub-assembly, bring up in-house. I think the world will kind of like come to a realization in the next few years that some of these like industrial humanoid businesses will grow at the pace of ChatGPT and OpenAI type companies with margins that are very similar to recurring businesses. Now what matters is low friction, high torque throughput, low heat dissipation, low maintenance. Those are the attributes that are actually going to win, not zero backlash. So we've made that bet. And again, for a lot of companies, they think that's blasphemy.
We have with us Sankaet Pathak, co-founder and CEO of Foundation. Thanks, Sankaet, for showing me your office, and thanks for doing the interview.
Yeah, thanks for coming by.
Let's start with talking about your journey. You made an unconventional shift from leading a fintech startup to founding a humanoid robotics company.
Yeah.
What sparked the motivation? Were you always interested in this space?
Yeah. I mean, I've been since college doing a lot of research in computer vision. So all of my undergraduate, graduate school, I used computer vision to do solar physics analysis. So we automated a bunch of stuff just using basic object detection, CNN stuff. So I've always been very fascinated about the concept of machines being able to understand our world. My last company in fintech, I pretty much started it to do back office automation, to be able to automate the back office of like a legacy industry. Then when I was thinking of, okay, what I really want to work on next, to me, it seemed like this was the right time of taking what I used to do. Like I'm like an electrical major, so I did tons of electrical work as well. Combine that with my love for computer vision and do something that like makes some good, meaningful impact in the real world.
Nice. So when Foundation came out of stealth earlier this year, right? You had a significant head start on the hardware side, at least, from the acquisition of Boardwalk.
Yeah.
So how did that relationship and the acquisition come about?
Yeah, I mean, Boardwalk came about because we were trying to figure out what actuators did we actually want to use in the robot we were building. We had tested out all the harmonic drive actuators that Tesla figure using. We also tested out like a bunch of things from China. We weren't that impressed with any of the actuator technology. Then we were referred to Boardwalk by somebody, and they said you should look at their actuators. They've done a great job with their actuator design. And we went there, we did our own tests. We ran kind of like all of this back drivability, max torque, max peak torque type tests. And theirs were like by far better than every other actuator we had tested.
Okay.
They had a higher torque throughput, they had lower friction. For a cycloid disc actuator, having close to zero backlash is like also was pretty impressive. So overall, they had like really good smooth design. They had only the upper torso at that point, so they didn't really have the lower torso of the robot. So then we decided we'll do the acquisition. Obviously, we'll combine everything we've been working on and accelerate the lower torso, and then make some adjustments on the upper torso. So that actuator design gave us a huge head start. And even now, as we are deploying robots, one thing that has consistently been impressive about the Foundation hardware is it has like pretty high uptime. And primarily that's because we have this like low gear, pretty much a low friction gearbox. So the heat dissipation is pretty low. So we don't have to, like the robot doesn't overheat and has to be turned off,
Right.
Which has really helped in being able to kind of like do these high OEE outputs, which is like what all factories measure output by, which is overall equipment effectiveness. And one big driver for that is being able to pick like a really good actuator technology that leads to like a much more reliable robot that can be on for a longer period of time. But that's how the Boardwalk thing came about.
Okay.
Yeah.
And why humanoids? So a lot of non-believers would say these industrial applications and use cases could be automated with an industrial arm or an AMR.
Yeah.
What would you say to that?
Uh, that's what I thought when I started Foundation as well. So actually, before I even started Foundation, uh, I did a bunch of factory tours just to be able to figure out what was the current state of automation, why wasn't everything automated, what would it take to automate stuff. And there were about two things that became quite clear to me. One, we really underestimate like the human degrees of freedom when it comes to automation. A lot of automation doesn't happen in factories is because the work required to be able to retool a process is just like way too much away from a human, while the human is like can accommodate a bunch of stuff and get it done. And then the second piece was like historically there has not been uh, pretty good deep vision based feedback into these processes. So like a lot of these robots are what I consider dumb robots. And what humans are again really good at that we really underestimate is like dynamic reasoning and not like very high IQ reasoning. It's more so a part comes down the conveyor belt, it stops a little bit sooner than you'd expect. It
Right.
might be in a different orientation. Your rack might be slightly different place, all these different things. And humans are really good at being able to take those small unstructured changes and still be able to do the task quite well. Historically, robots have not been. Like they're very tight tolerances. If parts doesn't come down exactly how you expect them, exactly where they need to be, your racks aren't exactly at the same place, the whole automation breaks. So they're kind of brittle for that reason. So those were like two reasons because of which we did not we thought this is why like factories are not 100% automated today. Um, then the other reason for that, outside of obviously, we think you cannot do industrial automation easily at a fast timeline without just trying to not change anything, just accommodate the human process and the way humans do it.
Okay.
The second big reason is you would not be able to manufacture as large numbers of robots, same form factor, same hardware, like millions or billions of units, if you had to customize that per use case. And we think at the end of the day, the economies of scale is what's going to win on a couple of different fronts. Technology and how good and polished it is,
Okay.
cost of hardware, how low it is, and third, data to be able to train very large, robust foundation models.
Right.
A precursor to that is deploying a very large fleet. So like if we have to keep on making updates to the hardware design, it's very hard to be able to logistically scale that fleet to a large size.
Right.
So those were kind of like the big observations, and we decided throughout my career, I've kind of like I constantly get reminded of the same lesson, which is in most cases the right answer is the obvious hard one.
Right.
And it's mostly wishful thinking and also futile for us try to outsmart the obvious hard answer. And the obvious hard answer is if you really want to automate all manufacturing, all of the logistics, all the work that humans don't want to do, you cannot expect those tasks to change differently to how humans do it. Another good reason why the biggest adoption of AI came from something like ChatGPT. It's a natural way to communicate. It does not really require a big change. You're talking to it like how you would talk to a friend. So like all those things played a big part and role in it. And I think same applies for robotics as well. If you really want real world autonomy, you want to get to a place where humans don't have to do things they don't want to do, it cannot be that the world is built differently for humans and differently for robots.
Okay. You mentioned the cycloidal gearboxes that Boardwalk and now you are developing in-house. Is there a reason why it's less common compared to other approaches?
Yeah. So the most common gearbox is your harmonic drive. And that has been pretty common in industrial applications for a long time. And the big reason for that is it has zero backlash. So what that really means is for the audience, like if you pick up an object from point A and you take it to point B, you want to be able to do that exact same motion millions of times, hopefully, or
Right.
maybe thousands of times. and you don't want any drifts. You don't want to arrive at X plus one or Y plus one, right? You have to
Right.
be very precise, which going back to the dumb robots tight tolerance.
Hmm.
So historically, it made a lot of sense to really, the primary KPI for actuators was zero backlash.
Okay.
But as soon as you incorporate vision-based feedback, that contemplation changes. Because now, even if I, just like with humans, if I arrive at a location I'm slightly off, I can just correct for it.
Hmm.
So now zero backlash isn't the most important thing. So then the question is, okay, what becomes the most important factor? And now this is where the industry diverges, right? So my personal opinion is now what matters is low friction, high torque throughput, low heat dissipation, low maintenance.
Okay.
Those are the attributes that are actually going to win, not zero backlash. So we've made that bet. And again, for a lot of companies, they think that's blasphemy. So by definition, they think like we're stupid for doing it. We think we have like very disciplined first principles thinking on this.
Right.
But that's why you still see a separation. Now, obviously, there are humanoids in China that are doing planetary gear, which is like similar concept. And I believe similar reasoning, which is, yeah, backlash isn't the most important thing to optimize for once you have vision-based feedback and you can correct for
Mm.
minor drifts.
So is the supply chain for the harmonic also more matured because of all those reasons?
Actually, I would argue the supply chain for cycloids is more mature
Oh, really?
because it's a very simple architecture. It's like ring pins, ball
Mm.
bearings, all of them we already manufacture billions of in the world.
Okay.
While the strain wave gearbox is so custom to just kind of like industrial automation. It's a much smaller market than like ball bearings
I see.
and ring pins and things like
Mm.
that. Uh, and they're also much more bulky, right? So you have to add torque cells to make them compliant.
Okay.
Because something like a cycloid disc essentially has like it's fully back drivable. So you can push against the grain of the motor motion. You cannot do that without a torque cell in a harmonic drive. If it's going one direction, because the gearbox is so inefficient, you cannot just take current and translate that down to torque.
Okay.
So what you really need is a torque cell that if it turns out someone's trying to oppose what you're doing, it detects it and rotates the motion,
Mm.
which essentially means the torque cell breaks, and like a human is sitting in its way, it's going to take your head with it. Versus with cycloids, and even planetary, like you don't have that as an issue. So it's also a much more simplified architecture because you eliminate like a big part that has a likelihood of failing. And then obviously you get a bunch of benefits like low maintenance and low wear and tear and things like that.
Right.
So,
You have big plans to scale up Phantom Humanoids. You want to make more than 10,000 robots by the end of 2027.
yeah.
Looking at the state of the supply chain, do you see any significant bottlenecks to achieving the target?
Uh, no, I think like we've already had enough investigation and conversations around this potential to be able to do like over 10,000 robots next year. I don't think that's where the supply chain would fracture. My gut is we're not at a place where the supply chain would not fracture if you were doing hundreds of thousands to millions. But tens of thousands, I think you'll be fine.
Okay.
Yeah.
And you are planning to
Yeah.
manufacture them in-house?
Our goal is to yes, manufacture more than 10,000 next year. We definitely want to do all the assembly, sub-assembly, bring up in-house. Currently, we don't do machining in-house. We're starting to do machining in-house in the next few months. So like TBD, how much of the machining we take to production, that really depends on how good we are at machining.
Mm-hmm.
But again, I'm like a firm believer in, I think America should learn how to machine. Like it's a key skill.
Right.
It is not in the country's best interest to have that be outsourced. And without machining, you cannot make any machines pretty much. So I think I also have like an emotional disposition to doing it and bringing it here. We'll see how successful we would be though.
Oh, great.
But definitely we'll do sub-assembly, assembly, bring up, testing, We might continue to do outsource machining for some of the parts or most of the parts, but I'm gunning for, at least for the parts we really care about, we want to start machining them in-house, even for production builds.
Okay. So Brett Adcock, your competitor, he recently mentioned that humanoids in industrial use cases is going to be a highly lucrative business. Customers are willing to pay good money. Is in your experience, does that align with your
That's
perspective?
absolutely true.
Okay.
Obviously there's like at its limit a price sensitivity, but it's so high that like essentially like today for equivalent labor, it's costing a factory close to anywhere between 140 to 160,000, not accounting for turnover and retraining. So potentially my gut is close to 200,000 to get the same output. So by the time you're kind of like below that number, I think you're fine. But you can also be below that number in a recurring revenue model, which is like insane. I think the world will kind of like come to a realization in the next few years that some of these like industrial humanoid businesses will grow at the pace of ChatGPT and OpenAI type companies with margins that are very similar to recurring businesses. Now, obviously, there are challenges you have to solve to be able to get there. Your BOM has to come below 100. So that like your overall kind of like payback period is in less than 1 year. Otherwise, it's just like untenable to get to a good margin profile. Second, you cannot have high breakages and maintenance cost. So that has to come down. Third, you cannot have like a totally teleoperated fleet. It has to be highly autonomous. So those are like three big facets. I feel pretty good about like pretty much all three of them coming down over time, not just for us, but as the industry generally. So that leads me to believe that like it's actually possible in industrial automation as it stands today, the early adopters, to your point, where the margin profile could be like higher than 70%.
Oh, wow.
Yeah. Not the first year, but the second year. Now, in the long run, that might not hold. In the long run, it might be if there is enough competition. Here, the assumption is enough companies are able to figure out how to build reliable humanoids with reliable AI and autonomy at scale. If that happens, I think there's going to be a price compression for sure.
Right.
But I think we're like a little ways away where like, I know we have a lot of humanoid companies that exist by name, but there are very few humanoid companies that have actually deployed a robot.
Right.
So I don't think we're as close as people think to like total commoditization. And my gut is like we're probably like 10, 12 years away. So you could have like 10, 12 year of really good run where you can deploy pretty large fleet, charge a good chunk of money for it. And then obviously the company that I believe would succeed is the one that does what Tesla did with cars, like aggressively build models that are cheaper and try to put them in the market as quickly as possible.
Right.
Like what is killing Model X and Y is well, Model S and X is actually Y, which is a better outcome than if Rivian was killing it. So like I think any company that follows that principle will probably still succeed, but definitely I think like you have a good head start.
Okay.
Yeah.
So I could say like 100,000 is the line.
I would intuitively think 100,000 is the line for every year. Yeah.
For next few years.
Yeah, because $100,000 at a price point, you can say it's at that point it's a no-brainer. You're saving money, you're getting more efficiency.
Right.
You don't have to worry about like all the turnover stuff and rehiring and all that stuff. So I think it's a good price point. So now the question is like can you bring the BOM cost and not just bill of materials, like bill of materials plus labor cost about or down to below 100.
So you mentioned about data collection earlier. So when it comes to AI, data scarcity is considered one of the biggest challenges. What are your plans on solving that problem as you add more use cases and deploy humanoids and different kinds of customers.
Yeah, I mean, data scarcity is definitely a challenge for achieving like robust general autonomy. And what I mean by that is you can tell a robot to do whatever task, and they've done tasks similar to it before, so it can reasonably do that task well. Definitely for that, we need a lot more diverse data. And for that, you have to deploy very large fleet. But data scarcity is not pretty much like an issue for like discrete autonomy, which is being able to solve for one specific use case and making sure you can run that in a robust, highly autonomous way, where like all the factory warehouse use cases are pretty much that. Like you have a very structured environment, and the robot's just doing by and large the same task again and again. Over there, data scarcity isn't as big of a challenge. It's more so like execution, so system integration. At this point for Foundation, like for those use cases, the hardware works, AI is kind of like getting pretty good. It's being able to make sure the whole system's integrated well, can be updated, versioned, and things like that. That's not as much of a data scarcity issue. Now, obviously, for the first thing, which is our eventual goal as well, get these robots to be just generally useful and be able to do almost anything that we throw at them. It's going to require deploying a very large fleet. But I believe how that's going to happen is you're going to have companies like Foundation that are able to get to high degrees of autonomy on specific tasks that then warrants deploying larger and larger fleets. And then eventually all of that comes together and you start seeing like model consolidation. At the beginning, you're going to have discrete models and then they're all going to start consolidating into a single model. So yeah, like I think the short answer to how you solve the data scarcity part is by essentially deploying the largest fleet. But to be able to get there, I do think there are enough use cases that are just available that don't have data scarcity as its like limiting factor. And I think like that's why it makes sense to start with those use cases first and then grow into the ones that are like truly zero shot, which is you haven't seen them before.
Right. So based on your experience in deploying Phantom in various real-world pilots, what were some of the key insights that your team has gained? Maybe that has informed your decision, or you've learned about what customers are expecting?
Yeah, I mean, what customers are expecting is for the robot to be able to do the job pretty much to the level of humans doing it. And the way they quantify that is with this metric called OEE, which is overall equipment efficiency, which accounts for uptime, which accounts for speed, which accounts for accuracy. And essentially, if you want to be like a very well-performing worker, your OEE is over 85%, which means like roughly 85% of the time you're doing the task in time without taking as many breaks and accurately. So that's kind of like the gold standard, what customers want us to hit and cross. Foundation's been able to now do that for over like 3+ hours. We've been able to cross 90% OEE.
Okay.
Now the goal is to extend that for the full shift. But the customer expectation is pretty straightforward. If we hit that number, we're successful. If we don't hit that number, we're not successful. But the things that I've learned, and that was like well known before we even like got in there, the things that I've learned that I was concerned about, and then new things I was concerned about was we're not going to be able to meet the OEE goals because the robot's not going to be reliable, it's going to break, or AI is going to take much longer to come close to autonomy, because we didn't really want to do a fully teleoperated fleet. Our customers didn't want it, it doesn't make sense. So we had to just target high autonomy day one. It's shocking in a good way to me that the robot is reliable. Like first generation robot runs for hours on end, multiple days, weeks, and does not break. So I'm pretty grateful we're there. The AI stuff, almost all of it is starting to come together. So I feel pretty good about that. The piece that is like a surprise, which is like probably sounds silly when I say it's a surprise, looking in hindsight, is it is definitely a lot of work to ship a robot from here receive the robot and deploy it. Like
Okay.
that does not happen in like an hour. It takes time. It
I
takes
see.
time for the team to receive the robot, bring it up, start deploying it, test it, calibrate it, things like that. So we do have long ways to go where you can just like ship a robot, it shows up, you open it, and it just like starts walking and doing the task. Um, so like I do think for the foreseeable future, there like companies like Foundation would have to have some kind of like field ops team, field engineering team that receives these robots, supervises these robots, even like does initial troubleshooting when something goes wrong. So I do think that's going to be like a little bit of an overhead for the foreseeable future. Obviously, to me, like a really good product is something you ship, the customer receives it, they just have to turn it on, and then everything works from there. But we're definitely like ways away from that.
Okay.
Yeah.
Uh, Looking at the evolution of AI for the physical world, uh, when do you think humanoids would be ready for home applications or even assistive applications for maybe healthcare?
Yeah, I mean, when would humanoids be ready?
Not also foundation.
Yeah,
Are you interested in that in longer term?
yeah. Well, I can answer when would we be, when I think the industry would be ready, then I can obviously answer like what we want to do about it.
Right.
Um, Depends what you consider ready. If what you consider ready is a teleoperated robot that you can just like deploy in a hospital or a assisted living, elderly living facility or homes, we're probably like an year or two away. Like we're pretty close. My sense is most people would not want a teleoperated robot in their home. Um, and also, we haven't talked about safety. Like, first, it has to be safe. Second, people have to believe it's safe.
Hmm.
And we still haven't achieved safety in a sense that even we as technical people are like, yeah, this is safe. Like, we're early adopters and we think it's safe.
Right.
So you have to first achieve that. I still think that's like a couple of years of work to be able to achieve safety to the levels you'd want in a home where you have pets and kids. Um, but then obviously the second piece is people have to believe it, and then the third piece is are people really comfortable around privacy implications to have this be teleoperated or someone watching you at your home.
Right.
So I do think we're like little ways off from there. As it comes to foundation, like the short answer is yes, like eventually we would do home use as well. Um, Now for me, the filter is pretty straightforward. Like, we want these robots to do things humans don't want to do. We don't want these robots to do things humans want to do.
Hmm.
So for me, what that really means is I wouldn't want these robots to walk my dogs, um, babysit my kids, take care of my parents. Like, I'd much rather do those things myself
Hmm.
or have like another human help me do it. Um, but there's also like personal preference, but like my personal preference would translate into like the foundation strategy, which is like we're going to be focused on, I do think you can do a lot of good by um, taking things off people's plate at home that they don't really want to do, because that gives you more time with family, more time for connection. I think that's what humans really love doing anyways. They want to be helpful, they want to connect with other humans. um, so I do think we'll do that at some point. I do, however, want to feel confident that before we do that, there's a path to going close to fully autonomous for manufacturing and logistics in 30-year time frame from now. Because like with declining birth rates, my concern is that we're not going to have enough humans in the labor workforce to manufacture the goods and resources. So then that equals high inflation, scarcity of goods and services,
Right.
and that'd be a much worse outcome for us. So right now, kind of like I think that's a bigger existential risk, and if I feel comfortable that us and everybody else combined, there's clearly a straight path to getting there, then obviously I think we'll start working on home use as well.
Cool. And one thing I found quite unique in your master plan was you're willing to do defense use cases, help U.S. Department of Defense and the allies with keeping the technological superiority. And that might look a bit different with humanoids, might need to be stronger, more agile. Are you already orienting your technology towards that?
Yeah, I do think right now, as far as I can see, there is a singular platform that works for both use cases, which is commercial and defense. Pretty much the requirements are by and large the same. You need a uh, like rugged robot that can lift a lot, like
Hmm.
basically speaking. Um, Now, obviously, as you start doing actual like active warfare type use cases, then your requirements diverge. Your industrial customers want the robot to be highly autonomous. A robot soldier needs to have a human in the loop, so more teleoperated than autonomous. Um, but that's also but I still don't think that's like a hardware platform change. So that's like more so software emphasis on AI versus teleop.
Right.
Um, so I do see like a direct path of doing it. We're interested in doing it because, like to me, the North Star for Foundation is we want to be able to deploy thousands of these robots in some remote place where no humans are there and be able to build the infrastructure and maintain that infrastructure um, so that humans can come there and live. Could be on Earth, could be beyond.
Mhm.
Um, and I don't think we're going to learn those skills in a car factory. We're going to learn those skills most likely in Department of Defense. So for me, the personal interest is that. Uh, Now, obviously, like I do believe that like you don't want to have excessive loss of life on one side over another. Like ideally, there are no wars, but then it doesn't seem like we have a propensity to stop getting in wars. So it's like, okay, then you don't want like disproportionate human suffering one way or the other. So I do think the best outcome over there is we end up with more automation. And currently, defense is already getting automated with drones, and you have like weapon robots already out. So this is more so like land automation as well. So I do think it's the right thing to do. My primary interest is in being able to really figure out how do these robots become kind of like enable humanity to be self sustaining pretty much anywhere. Um, and yeah, I think defense plays a big role in it.
All right. That's very exciting. That's all the questions I had.
Awesome.
Thank you so much for joining.
Yeah, thanks for coming by.
It was a pleasure talking to
Yeah,
you.
awesome.